Hi, Dr. Yearling here, and welcome to a guided concept map. In this unit, we are focused on learning about the human-microbe relationships, and we started off by learning about a world of microbes. Before we get started, I hope that you find yourself in a place where you can take 15 minutes and give your undivided attention. Remember, fragmented attention is poor retention. So, I moved my phone out of the room. I hope you can do the same. And I would also like for you to pull out some sticky notes, scraps of paper, flashcard notes like glossary or index cards, anything that will allow you to write down key glossary terms and actively build a concept map right along with me. I like the use of sticky notes or scraps of paper because then you can slide and move the terms around as you develop your understanding, and then you have the tools to come back and rebuild it later for practice retrieval. Okay, so pause the video if you need to, and then join me when you have those materials ready. So I divided the world of microbes into two major topics: the types of microbes and the human microbiome, which are the microbes that live in and on our body. Let's start with the types of microbes. I'd like you to pause the video and on each scrap piece of paper or sticky note, write down these key glossary terms and join me when you're ready. Okay, so I divided the types of microbes into two major categories. Look at the terms that you have written down and figure out how you could divide the types of microbes into two major categories. What terms would you need to put here? Pause the video, build that part of your concept map, and then come back to check your understanding. Okay, so the types of microbes can be divided into cellular and acellular. That's a major distinction for the types of microbes. Acellular only has two more branches coming off of it, so let's start with that one. What terms do you need to have branching off of acellular to finish that part of the concept map? Okay, if you said viruses and prions, you are correct. Both viruses and prions are acellular, meaning they are not made of cells. Let's now focus on cellular types of microbes. From there I have three branches. Let's focus on these two because they are very specific types of cellular microbes. Look at the terms we have remaining. See if you can make those branches. Okay, if you said that cellular microbes can be divided into prokaryotes and eukaryotes, you are correct. So a prokaryote is a cellular type of microbe that is distinct from a eukaryotic cellular type of microbes. What is one of the primary types of prokaryotes that we're going to learn about in this class? Look at the terms here and slide that one over. Okay, maybe you use some of the terms coming off to give you a little bit of a hint. The answer is bacteria. So I gave you two examples of types of bacteria that I find interesting. I asked you to watch the video The Edge of Wonder to learn about the human microbe and the complex relationship we have with the microbes that live in and on our body. Two microbes that stood out to me were Helicobacter and Fusiobacterium. I thought it was interesting that Helicobacter is bad for some people, seems like it could be good for others, and it depends on the context and the location. I think that highlights just how complex our relationship is with microbes. Fusiobacterium is found in 10 to 30% of colorectal cancer patients, and it gives them a worse prognosis. And actually, colorectal cancer is one of the leading causes of death from cancer in the United States. So I put that in there as well, due to the importance in medicine. So let's walk this concept map back to understand how these topics all fit together, or these key terms rather. So Helicobacter is a type of bacterium That is a prokaryotic cellular type of microbe. All right, let's look at the eukaryotes. There were 3 types that were given in this activity for you to know about. Of the remaining terms over here, which ones should slide in? Okay, so the answer is we have fungi, protists, and helminths. And there was a specific example that I gave and one that's going to provide to you context or anchoring your knowledge to something that you probably already know about, which we've learned is a good brain studying technique. Which of these remaining terms is an example of a fungi? Okay, if you said yeast, you are correct. Let's walk this map out. Yeasts are fungi, which are eukaryotic cellular types of microbes. Okay, we have one more branch coming off of cellular microbes. And we have 2 terms. Bet you can guess which one goes next. So I put binomial nomenclature coming off of cellular types of microbes because we learned that all living organisms get named using binomial nomenclature. Bi meaning 2, nomial name. 2 name. Nomenclature is the system for naming. So one that you're familiar with is Homo sapiens. That's our scientific name. 2 name system. Another one that you're probably familiar with is Escherichia coli. 2 name system as well. The first name is the genus. The second name is the species. So you might remember this by G, genus comes first in the alphabet before species. It's important to remember genus and species because not only does it tell us the name of the microbe in a way that anyone around the world could understand. If you were to say Escherichia coli, they would know what you were talking about, but it also tells us information about the relationship of that microbe to other living organisms. So genus, then species, and notice that the name is italicized and that the only letter that's capitalized is the first letter of the genus name. Okay, so the only remaining term that we have left is strain. So let's slide that down here. And I included that coming off of Escherichia coli because here are 2 different strains of Escherichia coli, O157H7, which is an infection that can be deadly. There's also Escherichia coli K through 12, which is safe for me to take into a kindergarten classroom and have 5-year-olds work with, despite the strange choices they may make. So this really emphasizes what I had in the reading. Same name, Escherichia coli, different strain. Has very different outcomes, potentially, for how we interact with that microbe and the impact it has on our lives. I also gave another example that all dogs are the same genus and species. Same name from a scientific perspective, but every breed we know can have very different traits. That's what strains are like for microbes. Oh, and one last tip. Don't say strand. It's strain. Sound like a professional scientist there. Strain. Okay, so we just covered the types of microbes, built out the concept map. Let's get a brief introduction to the human microbiome. We have a few terms to slide in there, but I also just wanted to give you a little bit of a different approach to learning about the human microbiome than we had in the reading. So first, let's start with location. Where's the human microbiome located? Everywhere on our body that's exposed to the environment. Skin, GI, respiratory, urogenital. Makes it really easy to remember. The world is covered in microbes, so any part of our body that's coming into contact with that world is going to also be covered in microbes. Now, if microbes get elsewhere, like the central nervous system, that can be one of the reasons that we would get infections and disease. And when I gave you the example in this case study of meningitis, which is a microbe getting into the cerebral spinal fluid and causing inflammation of the brain. Okay, human microbiome impact. we learned that they can be helpful, harmful, neutral. There are so many unknowns out there and a lot of fun that we will have as scientists exploring and figuring that out in the future. Another important thing to know about the human microbiome is how it exists. And there's a key term over here that was in your glossary terms. Which one describes how microbes exist? Okay, if you said biofilm, you are correct. A biofilm is a structured, complex community of microbes. They build this structure and they have this complex community in large part because they can produce a sticky matrix. And that allows them to adhere to surfaces as well as to each other. And putting all of that together, this structured, complex, sticky matrix of microbes, gives us an important outcome that this protects these microbes from harsh environments and chemicals. So you could imagine that a biofilm on a medical device is a much more serious situation. We've all experienced biofilms in our life when you scrub around the sink drain and then a week later, it's back. They're very hard to get rid of. And they also protect microbes from like antibiotics as another example. The basic timing of microbes in our life will be resident, those microbes that live on our body throughout our lives. It's pretty typical to see them. And then transient, ones that come and go. Maybe you have it for a little bit because you're sick and then your immune system fights it off, or you get on antibiotics and it goes away. All right, so let's zoom back out. In this activity, we learned about the world of microbes in a very introductory way. We talked about the types of microbes that you might experience as a healthcare worker and the human microbiome and how that relates to medicine. So practicing our brain science learning techniques, we're about at 12 minutes out. So I encourage you to take a break. You can go for a walk, do something that engages your brain a different way, even folding laundry and letting your mind wander. Come back and see, can you build this mind map again? Or maybe leave the mind map up and see if you can talk out loud through the connections that we made, explaining it to someone else. Both of those would be wonderful ways to practice retrieval, which is what you're going to want on our exams. All right, thanks for watching. Bye for now.